Hi everyone, the video is a full class of Kubernetes deployment. The class includes all deployment related concepts and hands-on demos. First section, Ingress. This section includes 4 ways to expose application in Kubernetes. And what is Kubernetes Ingress? How to enable Ingress in Minikube. Create an Nginx Ingress resource. Next section, Ingress Advice. In that section, we'll learn how to get Minikube Nginx Ingress controller configuration detail and add Nginx Ingress controller customization parameter. Retrieve Ingress object config detail. Add Nginx Ingress object customization parameters. After we're familiar with the Ingress, next, in blue-green deployment section, we'll focus on concept of blue-green deployments, create blue deployment and Ingress resource, and then demo create green deployment and Ingress resource. Latest, switch network traffic from blue deployment to green deployment. Next section, Canary Deployment. What is Canary Deployment? And then demo how to implement Canary Deployment with Ingress. Latest section, Rolling Update Deployment. In that section, we'll learn what is Rolling Update Deployment, and then demo Rolling Update Deployment. Let's start Ingress. Topics for today: how to expose applications in Kubernetes. What is Kubernetes Ingress? And a demo how to create Nginx Ingress. First topic, how to expose application in Kubernetes. First, traditional way, Kubernetes Ingress. Ingress can redirect user network traffic to backend service based on the domain name or domain name plus path. There are a lot of Ingress implementation in the market, such as Nginx Ingress, HA Proxy Ingress. Usually the Ingress implementation has 2 versions, free version and commercial version. Based on your requirement, you can choose one of them. Ingress supports hard load configuration file when you create a new Ingress object. If Kubernetes cluster huge, the hard load configuration file will be performance bottleneck. Next, use service mesh to access apps in Kubernetes. For example, Traffic, Envoy, Istio. Service mesh natively support microservice in Kubernetes. In the future class, I will compare service mesh and Ingress. And then in Dev environment, I can expose cluster IP or node port to allow network traffic access to the service directly. Finally, network load balancer. Cloud providers such as Google Cloud, Azure, AWS provide network load balancer that allow user access service. Next topic, what is Kubernetes Ingress? The Ingress is an API object that manages the external access to the service in the cluster. Also, Ingress support load balancing user network traffic to service. Also, Ingress support name-based virtual hosting. For example, there is a Spring Boot demo Ingress. The Ingress able to redirect springbootdemo.com network traffic to Spring Boot demo service. There are 2 deployment types for Nginx Ingress: daemon side deployments. On daemon side, will deploy NGS Ingress to each work node. Outside network load balancer will randomly redirect network traffic to each work node. And then Kubernetes Ingress will, based on the redirecting rule, redirect the network traffic to the service. Second, deployments. Deployments type like regular service deployment. Only one Ingress service in Kubernetes cluster. In outside, load balancer only need to point the Ingress service. There is a network logic flowchart. Kubernetes Ingress controller is able to hard load Ingress objects. That means Kubernetes Ingress controller has network redirect rule. The rule is based on the domain name or domain name plus path or virtual host in Kubernetes cluster. There are 3 steps for network traffic. First, users send network traffic to Kubernetes Ingress controller, and then Ingress controller, based on the redirect rule, send the user network traffic to the Kubernetes service. Latest topic for today: create a NGX Ingress. There is 2 main parts in my demo. First, enable NGX Ingress in Minikube cluster. Second, create the Ingress object and test it. Start my demo. Connect to my local Minikube box. In demo, I'll create NGX Ingress objects. The object has a redirect rule. Any network traffic start from springbootdemo.com will redirect to Spring Boot demo service. Further steps: enable Ingress in Minikube. Run follow command to enable Ingress. Minikube add-ons enable Ingress. Next, check Ingress add-on status. Ingress enabled. Next, get Minikube IP. Minikube space IP. The command is able to retrieve Minikube IP. And then add domain name and IP to the host file, because the domain name is not a real domain name. Outside DNS doesn't have the domain information. So I have to add the IP address and the domain name to host file. Check host file. (192.168.49.2). This is Minikube IP address. springbootdemo.com. This is test domain name. Next, restart Minikube service to enable Ingress add-ons. Start. Check status. It's running. And then go through the YAML file. There are 2 YAML files we use in our demo. First, YAML file create Spring Boot demo service. That's the same file I used the previous class, no change. The file is used to create a deployment resource. The resource will be create 3 Spring Boot demo pods. In other words, the replica size equal to 3. Next file, ingress minor demo minor v1.yaml file. The file is used to create ingress resource. Go through the file. The file has three parts: API version, metadata, and spec. The API version is network.k8s.io/v1. The kind is a resource type, is ingress. Since previous class we install Kubernetes plugin, when your mouse move to here, there's more detailed information. Metadata, this is ingress object name, ingress minor demo. Also we created the ingress object in K8s minor training naming space. Spec, the rule is match the rule spec rules. The host is equal to domain name. Our domain name is springbootdemo.com. Protocol is HTTP. Passes has a path information. First, the path is a root path. There's a path type in that URL. The URL has more detail about the path information. Path type, prefix. That means any network traffic start from springbootdemo.com will redirect to backend service. The service name is Springboot Demo. The port is 9999. kubectl apply minor f first YAML file to create Springboot deployment resource. And then create an ingress resource. Next step, check ingress deployment type. In Minikube, the deployment type should be deployment, not daemon side. In Minikube, ingress deployed to the kube system namespace. So when I run kubectl get deployment resource, I have to add naming space kube minor system. There is ingress Nginx controller. kubectl describe deployment plus deployment resource name is able to retrieve deployment detail. Host port. The ingress controller monitor 80 as HTTP and 443 as HTTPS. Use a curl to access our springbootdemo.com. Version is v1. That means ingress redirect springboot.com network traffic to our backend Springboot demo service. There's other endpoint in the Springboot demo service. The path is /SOS. Also, I use GQ to format JSON result. Run 3 times. By the way, the API is able to retrieve port IP address and the environment parameters. 0.6, this latest access. The second time access, ingress redirect our traffic to other port because the IP address is different. In the first time, it's same IP address. Because the ingress load balancer algorithm is a red robin. Today we learned Kubernetes ingress. Expose application in Kubernetes. There is 4 ways: ingress, service mesh, network load balancer, And in daily environment, we can use cluster IP or node pod to access service. Also, we learned what is a Kubernetes ingress. It's object able to redirect user network traffic to the Kubernetes service. Latest, do a demo to enable Nginx ingress in Minikube and create an Nginx object for Spring Boot demo service. Also use curl springbootdemo.com to access Spring Boot demo service. Ingress session is completed. Let us move to next session, Ingress Advanced part. Hello, and welcome to our class. Today we learned Nginx Ingress Advanced part. There are 4 topics for today. First, how to get the Minikube Nginx Ingress controller configuration detail. Second topic, I'll demo add Nginx Ingress controller customization parameter. Third topic, how to get Nginx Ingress object configuration detail. Latest topic for today, I'll demo add Nginx Ingress object customization parameter. Log into my Minikube box. First topic for today, how to get Minikube Nginx Ingress controller configuration detail. Nginx Ingress has different deployment config for Minikube and Kubernetes cluster. Even there's a different deployment config for different Minikube version. So first, I have to check Minikube version. Command is Minikube version. The version is 1.18.1. Next, retrieve current Nginx Ingress controller configuration. Since the Nginx Ingress controller in kube system namespace, we switch current namespace to the kube minor system. After we run this command, we don't need to add minor n parameter for following commands. Next step, current Nginx config information in the Nginx Ingress pod. So get a pod list first. There is Ingress minor Nginx minor controller pod. The pod has current Nginx Ingress controller configuration. Copy the pod name. Next, get the pod detail. Command is kubectl describe plus resource type and resource name, able to retrieve resource information. In our case, we use kubectl describe pods plus Ingress Nginx controller pod name to retrieve controller's detail. Naming space in the kube minor system. There's the IP address, start time, label. There's no annotation. The Nginx Ingress controller monitored 2 ports in the host, 80 for HTTP and 443 for HTTPS. Argument is important. There's the configure map name parameter. Current Nginx minor load minor balancer minor config. This is current configuration file for Nginx Ingress. Also there's status, pod name. Final steps, go to pod, get the configuration detail. kubectl exec -it interactive mode plus pod name. sh is a port endpoint. Command is ls. nginx.config is nginx ingress controller configuration file. Use cat command to retrieve the config file detail. There's a balancing information. Location / there's default redirect configuration information. There's some proc redirect parameters. Next topic for today, how to add customization parameters to the nginx ingress controller. As I mentioned before, there are different deployment config for different Minikube version. So go to Minikube Git repository to retrieve detail. Change the tag for your Minikube version. Deployments, add-ons. There's all add-on deployment file under the add-ons folder. Ingress. Configuration map. There are default configuration map. We can add our customization parameters on the first configuration map. This URL has all support configuration parameters. The parameter list in there. Let me change proxy read timeout parameter. This is config name. kubectl edit configure map plus configuration name is able to edit existing configuration map. There one data in there, add one more. Proxy read timeout. We copy the key. Value we change it to 10. Proxy read timeout. Default value is 60. Push ESC key to save and quit. Same command as vi. Get pod. Get pod name. And then check pod log. kubectl logs plus pod name. There is useful information. Configuration changes detect backend reload request. Backend successfully reload, meaning reload to our customization parameters to nginx ingress controller. There's reasons. Reload, nginx reload triggered due to a change in configuration. Log into the pod again, change the parameters. Use grep to filter the nginx.config file. Proxy read timeout, change to 10. There's one thing I need to mention. nginx config items name not equal to configuration key in the document. So please follow that page to edit your configuration key in the configuration map side. If you directly copy the key name from the nginx.config file directly and try to edit, the value couldn't be changed. For our demo, we changed the global parameters in nginx ingress controller. How do we retrieve and change individually Nginx Ingress object. This is our next topic. How to get Nginx Ingress object configuration detail. That's Ingress demo object we created in previous class. If you don't have created yet, please review my previous class. We use this command, kubectl describe ingress name. The naming space is k8s minor training. The command will retrieve the ingress object details. This redirect rule is if network traffic to springbootdemo.com will redirect to the Spring Boot demo service. Port is 9999. Since we set up the service replicate site equal to 3, there's a 3 ports IP. Because Nginx Ingress controller doesn't use the service to access a port, Nginx Ingress controller redirect to user network traffic to port directly. That way can enhance performance. Let me change the port size and see there's a port IP address change. The command uses kubectl scale deployment / Spring Boot deployment object. Reduce the port size from 3 to 2. Naming space is k8s minor training. Successfully. Recheck the Nginx object detail. There is a change. Previous was 3 port IP address. Since we reduce the size from 3 to 2, the IP address is 2 in there. Latest topic for today, I will demo how to add Nginx Ingress object customization parameters. First, delete existing Ingress objects. I use add Kubernetes annotation to specify Ingress object to customization their behavior. There's a link for the all support annotation in Kubernetes Nginx Ingress objects. Go through the file first. I put this file on GitHub, so go through the file first. There's 3 parties here. API version is v1. Type canned is ingress. Metadata name ingress demo. This ingress object name. Naming space k8s. Minor training. Annotation in there. This will be our customization parameters for Nginx Ingress controller. Process read timeout, send timeout. Load balancer type. Default is a write robin. We change to EWMA. Other part are same. Apply the YAML file to create Ingress object with annotation. Use the describe command to retrieve the Ingress demo resource. There's 3 annotation parameters we added from our YAML file. Get the pod name. Check the Ingress controller pause log. There's event. Reload configuration file for object Ingress demo. Reload the reason because we create new objects. Go through the pod to check the configuration. This section has our customization parameters information. The domain name mapping to springboot.com. Proxy read timeout, the value from my YAML file annotation. Let us test the Ingress objects. V1. Try to get system information detail. Further, get this one port. IP address is on 0.6, and then we run second time, hit to the 0 on the file. If you're interested for the load balancer type, you can go to the Ingress website. There's more detailed information. Today, we focus on the Ingress Advice parts. First, learn, go to Ingress controller pod to retrieve Minikube Ingress controller configuration detail. Please remember, Ingress has different deployment config for Minikube and Kubernetes cluster. Even there's different deployment config for different Minikube version. Next, I demo how to edit configuration map to add Ingress controller parameters. And then we learned how to retrieve Ingress object detail. In latest demo, I used annotation of Ingress controller object to add customization parameters on Ingress objects. After 2 sessions, I believe you're familiar with the Ingress. Let's start discovery blue-green deployment. Welcome to our class. Today we will learn blue-green deployment. There are 2 topics for today. First topic, what is blue-green deployment? Second topic, I'll demo how to implement blue-green deployment in Kubernetes. What is a blue-green deployment? A blue-green deployment is a way of accomplish a zero downtime upgrade to existing application. The blue version is current running application. In my demo, blue version is a Spring Boot demo v1, and access URL is www.springbootdemo.com. The green version is new version. In my demo, the application version is Spring Boot demo v2, and access URL is test.springbootdemo.com. Once the green version is ready means QA and UAT test no issue. Network traffic will redirect from blue to green. Kubernetes has a really awesome built-in feature called deployments. Deployments come with the ability to rolling upgrade of container. When you upgrade your application to new version, rolling upgrade a great way to upgrade application because your app uses about the same amount of resource during upgrade, always minimum impact to performance and availability. Rolling upgrade do not need additional resource when your app upgrade. However, there are many legacy applications do not work well with the rolling upgrade. Some applications simply needs to apply a new version and cut over to it right away. For this, we have to use the blue-green deployments. With blue-green deployment, a new copy of the application is deployed alongside the existing version. When the green version is ready, switch the network traffic from blue to green. If you'd like to get more background about green deployment patterns, there is a link, the document from the Martin, who is create the concept blue-green deployment. The diagram shows my demo 3 steps. First, create a Spring Boot demo v1 deployment resource, and the blue Ingress resource to redirect www.springbootdemo.com to Spring Boot Demo v1 backend service. Second step, create a Spring Boot Demo v2 deployment resource and green Ingress resource to redirect test.springbootdemo.com to Spring Boot Demo v2 backend service. Latest step, update blue Ingress resource to redirect www.springbootdemo.com to Spring Boot Demo v2 backend service and delete green Ingress resource. Let's start my demo. Log into my Linux box. Start up my Minikube. First step, create a blue deployment. Our goal is when the user accesses www.springbootdemo.com, network traffic will redirect to Spring Boot Demo v1 backend service. Enable Ingress add-on. Next, add IP address and domain name into host file. Check result. The IP address is Minikube IP address. This is our test domain name. Before we create a resource, go through the YAML file change first. Based on the previous YAML file, resource name was changed. Add more information on the metadata. Also, based on the new metadata information, selector also needs changed. Let's start. Go through each detail. Add new metadata version information. Version value is v1 in deployment resource, pod, and service. Let me quickly go through the file. Naming space no change. Secrets and configure map same as before. Deployment resource, we add metadata information. We add version information under the metadata parts. Replica size is 3. In the pod template, add version information in the metadata parts. Service part, version value add to the selector to make sure the service pick up right port. Apply the YAML file. There are two ways to apply the YAML file. One from my GitHub repository, or you can download the file to your local and run. kubectl apply -f plus file name. Create successfully. Launch a BZBox to test the service. I use the BZBox. Which one has a curl tool? Use a curl command to test the service. Need at port 9999. Retrieve the version of the backend service is v1. Next, create a blue Ingress. Go through the YAML file. The content same as our previous class. API version is v1. Canned is Ingress. Metadata. There's Ingress object name, naming space. The Ingress redirect to is if the user accesses www.springdemo.com, will redirect to service. Spring Boot Demo v1. Port number is 9999. Ingress created successfully. Use curl to access test domain name and able to retrieve the correct app version information v1. That means Ingress object working successfully. We completed the blue deployments. Next piece, upgrade the Spring Boot demo from v1 to v2, and then create green deployment resource for Spring Boot demo v2 resource. The goal is redirect .springbootdemo.com to Spring Boot demo v2 backend service. First, add the Minikube IP address and the mapping test.springbootdemo.com record to the host file. Check result. There are two records of add for today testing. First domain name is for blue host name. Second domain for green deployments. Let's go through the green deployment resource file. Since naming space, secrets, and configure map were created, we don't need to create again. So this file create deployment directly. Only difference here, change the version value from v1 to v2 in green deployment file. Deployment version is v2. The information under the metadata section. Replica same as before is 3. Pod template add version v2 information under the metadata parts. API service in selector section add version v2 information. Apply the green deployment YAML file. Check pod information. Spring Boot demo v2 pod created in progress. All is running. Start a busy box to verify Spring Boot demo v2 service. Port number have to add since we don't use the 80 port. The full command is curl space service name and the port number. The curl retrieve the correct version number is v2. Next, create a green Ingress resource. The resource will be mapping test.springbootdemo.com to Spring Boot demo v2 backend service. API version canned Ingress, metadata, Ingress name. Redirect is mapping network traffic test.springbootdemo.com to Spring Boot demo v2 backend service. The service port is 9999. Apply the file. Next step, text green Ingress resource. Retrieve the v2 version is correct. After test, Spring Boot demo v2 service completed. Let me show how to switch the network traffic from blue to green. kubectl patch command used to upgrade existing Kubernetes resource. Resource name is blue Ingress demo. Blue Ingress demo. Upgrade type is JSON. Parameter first. Operation is replace. Path is spec. Rules. first rule for the HTTP. Passes, select 0, first pass. Upgrade backend service name to v2. Naming space is Kate Ice training. Upgrade field because the path incorrect. Let me add one more select between the service and the name. One more select needed in there. It's patched. Test the result. Version is upgraded to v2. Test successfully. Latest steps: delete blue Ingress demo resource. Kubernetes delete resource command pattern is kubectl plus delete and resource type and resource name. If necessary, add naming space. Demo completed. Today we learned the concept of blue-green deployments. Also run the demo. First, we create a blue deployment and Ingress resource, and then create a green deployment and Ingress resource. Finally, show how to switch network traffic from blue to green. Welcome to Canary Deployment session. Today we will focus on the Canary deployment. 3 topics for today. What is Canary deployment? How to implement Canary deployment with Ingress. I'll demo how to configure Canary deployment in Kubernetes. What is Canary deployment? There are 2 diagrams. First is traditional deployment. Second is Canary deployment. These are existing app version v1 in production, and the user use www.springboot.com to access our app version v1. Next, use Canary deployment with app v1 and v2. In the app version v2, we add new functions. When user access www.springboot.com, 90% of user will access existing app version v1. 10% of user will go app version v2 to try new function. That's Canary deployment pattern. A Canary deployment or Canary release is a deployment pattern that allows you to roll out new code or function to the subset user as an internal test. In that diagram, 10% user will do internal testing with app version v2. Canary release is a technique to reduce the risk of introducing new software version in production by slowly rolling out. From my view, Canary deployment is a super blue-green deployment. In blue-green deployment, switch new function for entire user. In Canary deployment, switch new function for subset user to reduce the risk. The name of this technology originates from miners who will be carry a canary into the cage down the core mines. If the toxic gas leaked into the mine, it would kill the canary before kill the miners. A canary release provides a similar from the earlier warning for the potential problems before impacting your entire users. Second topic, how to implement Canary deployments in Minikube Nginx Ingress. First, enable Ingress add-on in your Minikube cluster. You have to and then enable Canary in Ingress resource. There are 3 Canary types. First, based on the header. When the Ingress find the user network traffic has a special header and then redirect user requests to the new version. Next, cookie type. Ingress resource based on the user request cookie, redirect user to the new version of application. Third, Canary type. Based on redirect percentage, Ingress randomly redirect user requests to the new version of app, as above diagram. The three Canary type is able to use individually or combine 2 or 3 together. If combine 3 or 2 together, the priority is from high to low, canary by header, canary by cookie, canary by weight. From my view, canary by header is better, because canary by cookie, you have to add additional code to renew the cookie. Canary by weight means randomly send the user to a new version. When the user faces the bug, need more time to analyze. Latest topic for today. I will show how to implement Canary deployment in Kubernetes. Log in my terminal. First step, enable Ingress add-on in Minikube. Check Minikube IP. Next step, add Minikube IP and www.springbootdemo.com into host file. If you follow my previous class, there is IP address and www.springbootdemo.com was in your host file. If not, run above command to add the domain and the Minikube IP in your host file. Let me check my file. My host file hides this IP address and domain mapping information. Why we need to add the domain name and the IP address to the host file? Because www.springbootdemo.com is not real domain name, only used in our test purpose. The no DNS has record www.springboot.com point to my Minikube IP address, and then create app version v1. There are 2 ways. One way, retrieve the YAML file from Git repository directly to create below resource, or you can download the entire repository to your local, apply the file to your local directly. I use the second way. Before I apply the file, let me go through the file. Same file we used the previous class. First, create a naming space. Naming space name is Kubernetes training. Create a secrets and configure map. 2 resources used in our Spring Boot Demo v1 service. Their deployment. Replica size equal to 3 in deployment. The pod template. The image is Spring Boot Demo v1. Also mount configuration map and secret in the pod. The service. There is a version selector in the service. The service uses selector select the pod, which one version equal to v1. kubectl apply minor f plus YAML file name. Check resource. Use kubectl get all plus naming space parameter Kubernetes training to retrieve above created resource. First is the pod information. There are 3 pods created based on the replica parameter. Status is running. service created, deployments also created, replica side resource in there. Go next steps, create Ingress resource. When the user accesses www.springboot.com, the Ingress will redirect user traffic directly to the Spring Boot demo service v1 pod. Go through the YAML file. This Ingress YAML file. The name is Ingress v1. Naming space K8 training. Annotation at ingress.class equal to Nginx. The rule is any network traffic to www.springbootdemo.com will redirect the traffic to the Spring Boot demo service v1. In behind the scene, Nginx Ingress retrieves the service pod information. The network traffic will go to the pod directly, avoid service layer to enhance performance. The port is 9999. Ingress resource was created. There's a curl plus domain name to access the service. The version value should be v1. Successfully. Third step, create a v2 Spring Boot microservice. Go through the YAML file. Same as the Spring Boot demo v1 YAML file. The difference in the version number changed from v1 to v2. All the resource created in the K8 training namespace. Replica value is same, is 3. There is different in the pod template. The image version from Spring Boot demo v1 changed to Spring Boot demo v2. Selector also changed from version v1 to v2. The YAML file will create a deployment pod service. Check result. 3 pods for v2. Service v2 resource created. Deployment replica site were created. Next, create a weight-based ingress resource. Go through the YAML file. API version is v1. There are 3 parts in the YAML file. First, app version information. The value is v1. Canned ingress, metadata. The name is Canary weight ingress. Naming space K8. The annotation used to enable Canary deployment and the rule for the Canary. Nginx.ingress.kubernetes.io/canary value equal to true. The annotation means turn on the canary function in Nginx Ingress. Second, the canary rule is canary minor weight 50, means Ingress randomly select 50% user network traffic to Spring Boot demo service v2 version. Others the same. House mapping information www.springbootdemo.com. The path is a root. Spring Boot demo service v2. Port is 9999. Create successfully. Use curl to test. Curl space www.springbootdemo.com. v2. That means Ingress resource redirect to the network traffic to Spring Boot demo v2 service. Run again. The third request redirect to the network traffic to v1. I tested 10 times, 30% network traffic go to Spring Boot demo service v2. Since the algorithm is randomly, I believe if I continue to run more testing, for example, 100 times, the percentage will close to the 50%. Delete this Canary deployment. Next, try the Canary by header. You can combine the two routes together, but it's hard to show a clear result. So delete current Canary by weight ingress. Go through the Canary by header ingress resource YAML file. Version info can is the same. Made two new annotations. First, Canary by header. Second, Canary by header pattern. There are two lines combined in one rule. If the ingress find user header has a key value pair, the key is a region, value is VA or MD, while redirect user request to app v2 version. Rules is the same. Host www.springbootdemo.com. Path is root. Service Spring Boot demo service v2. Port 9999. Curl domain name plus minor h means header. The key is region, value is VA. This request should go to the v2 version. The result value is v2. MD is v2. If we change the version to the CA, California, will be go to the v1. Region equal to DC, go to the v1 version. Why region CA and DC go to Spring Boot service v1 version? Because our Canary header pattern value is VA and MD. Demo finished. If you want to get more NGIS ingress annotations, the URL has the more Canary annotation detail. Today we learned the Canary deployment is a deployment pattern that allows you to roll out a new feature to subset of user for the internal testing. How to implement Canary deployment with Ingress. Use annotations. There are 3 Canary types supported by NGIS Ingress: header, cookie, weight. You can also one of 3 or combine 2 or 3 together in Canary deployment. Also, I show how to run this Canary deployment in the Minikube with the Canary by weight and Canary by header. Welcome to latest session, rolling update deployment. Today we'll cover rolling update deployment. There are 3 topics for today. First, what is deployment? Second, how to rolling update with deployment. Latest, I'll demo rolling update with Minikube. What is deployment? Deployment provides a management method for pod and replica site. Kubernetes is declarative system. It means I cannot see, run this container. All I can do, describe what I want to have and wait for Kubernetes to take action to do it. The relationship of 3 resources are from high to low. Top level is deployment, is a manager of replica sites. Second level, replica sites is maintain pods. Third level is pods. Pods include containers. Second topic, how to rolling update with deployment. Users expect applications to be available all the time, and developers expect to deploy new versions of them several times a day. In Kubernetes, this is done with the rolling update. Rolling update allows deployments update to take place with zero downtime by incrementally updating pods instance. The new pods will be scheduled on nodes with available resources. A deployment rollout trigger is pod template change. For example, if the labels or container image of the template are updated, the rolling update is triggered. Please remember, in API version apps v1, a deployment label selector is mutable after it gets created. Other updates, such as scaling the deployment, do not trigger a rollout. There are two ways to rolling update. First way, update image. Command is kubectl plus naming space if you don't use default naming space. Set image. Deployment name, container name, and image detail. Plus minor record equal to true. Recording equal to true is used to save command to rolling update history. Second way, apply update YAML file. Command is kubectl apply -f plus YAML file name and minor record equal to true. Strategy parts are able to add to pod template session in YAML file. The more configurable item, then update image. There are two strategies, recreated and rolling update. Recreate means all existing pods are killed before new ones are created. That means downtime in update process is not best practice. Second, rolling update. This is default strategy. There is no downtime in rolling update strategy. 5 parameters under the rolling update strategy. First, max unavailable. The parameter control how many pods allow unavailable in the rolling update process. The parameters can be number or percentage. For example, 10%. The default value is 25%. Second, max surge. Max surge specifies the max number of the pods that can be created over the desired number of pods. The value can be absolute number or percentage of desired pods. Default value is 25%. Max unavailable and max surge need to work together. If I have enough resource and I want to quick update, I can set up max unavailable equal to 0. That means before new pods ready, do not kill any old pods. And then set up max surge equal to 100%. That means start up all new pods immediately. If you don't have enough additional resource, default value 25% is fine. Third, progress deadline seconds. That field provides option number of seconds you want to wait for your deployment to progress before the system report back that deployment has failed progress. The default value is 600 seconds. Minimum ready seconds. That means be considered app available access after pod created. Default value is 0. Minimum ready seconds is based on your app start time. Please test first and then set up the value. Reversion history limit. The parameter used to control how many previous replica sites saved in the Kubernetes. In other words, how many previous deployments are able to roll back. Demo, the latest topic for today. Before start demo, let's set up the environment. Log into my Linux box. First, check Minikube status. Minikube running successfully. Second step, enable Ingress add-ons. Ingress add-on enabled. Third, retrieve Minikube IP. Use this command to add Minikube IP and www.springbootdemo.com into host file. Because our testing domain www.springbootdemo.com is not real domain name, only for our test purpose, so no DNS has the record mapping information. We have to add this IP and the domain mapping information to our host file. Check result. Item was added. Next, create deployment, replica site, pod, and Ingress resource. Use rolling update demo v1 YAML file. Go through the file. Create a naming space. All the resources created in the KTS minor training naming space. The naming space is used to avoid resource name conflict in your local environment when you run a demo code. Create a deployment. Deployment resource name is rolling update deployment. Replica site is 10. The parameter means create 10 pods. Template. The container name is Spring Boot Demo. Image Spring Boot Demo v1. Port is 9999. Next section, create a service. Service use selector to select a pod which has label app value is Spring Boot Demo. Forward port as a deployment pod port definition. And then create an Ingress resource. The Ingress resource redirect end user request from www.springbootdemo.com to backend rolling update service. Apply the YAML file. I put the YAML file under the rolling update deployment folder. The file you can download from my Git repository. The repository link is under the video. kubectl apply -f plus YAML file name and enable record equal to true. All resources were created. And then check deployment resource. kubectl git deployments -n meaning naming space. Naming space name is KTS minor training plus deployment name. In deployment, replica site value is 10. Right now, 9 of 10 pods are ready. 1 pod created in progress. Check again. All the desired pod is running now. And then check pods information. 10 pods are running. The number equal to replicate desired. Next, verify the image information under the pod. kubectl describe pods plus naming space and pod name. There is image information inside the pod, Spring Boot Demo v1. Next, check replica site resource. The desired pod is 10, current is 10. Also, ready pod number is 10. That means replica side running as our desired. Use curl command access www.springbootdemo.com. Return value is current microservice version. The value should be v1. Curl command will through ingress resource, service resource, and pod resource to retrieve the return value. All request resource is created and verified. Start first demo. Use set image to rolling update. kubectl naming space parameter and set image. Deployment / deployment name and container name Spring Boot demo equal to 链段 training / Spring Boot demo v1 plus minor record equal to true. The command used to rolling update deployment. The container image upgrade from Spring Boot demo v1 to Spring Boot demo v2. Minor record equal to true. Save the command into rolling update history. Open other terminal to monitor rolling update status. Roll out one by one. The default strategy for the setup: create a new pod under the new replica site first, and then delete previous pods. Previous replica site still keep in the system for undo purpose. In the rolling update process, if you want to pause the rolling update process, roll out pause command is able to pause your rolling update process. If you want to continue, you can use rolling resume, continue your current rolling update process. Check deployment resource detail. Use kubectl naming space parameter describe deployment and deployment resource name. Create a new pod with the update image. Scale down means terminate previous pod. kubectl naming space rollout history and deployment plus deployment name used to retrieve rollout history. There are two histories for rolling update deployments. First created, second rollout. If you want to save your rollout command into history, please add minor record equal to true. Clean up existing deployment resource before I run second demo. Recreate test baseline. Second demo for today. Use YAML file to rolling update. Go through the YAML file. The two parts were changed. First, add strategy under the spec. Second part, image version changed from Spring Demo v1 to Spring Demo v2. Go back to first part. Strategy was added. Tab is default tab, rolling update. Under rolling update, there are two parameters, max search and max unavailable. Under rolling update, max search equal to 2. That means allow 2 additional pods were created when rolling update process. Second parameter, max unavailable pod, number equal to true. That means in the rolling update process, there are 10 pods. Only 2 of 10 pods allow unavailable. Second part is only for version change. use kubectl apply -f rolling update demo v1.yaml file. The command is kubectl apply -f rolling update demo v2.yaml -record equal to true. The command is to use rolling update. Open other terminal to check status. In progress. Open other terminal to pause the process. The rolling update process paused. Use kubectl -n plus naming space rollout resume deployment / deployment name to continue the process. Check status. Process was completed. Use describe command to retrieve the deployment resource detail. The command is kubectl -n plus naming space describe resource type is deployment. Resource name is rolling update deployments. The highlighted parts from deployment file strategy section, minimum ready section. Old rubric size is previous version rubric size. New rubric size is current version rubric size. How to check the rollout history? The command kubectl -n space name rollout history deployment plus deployment name. There are two records. First record initialized the environment. Second record did the rolling update. Check rollout version. Next, verify API version. The value should be v2. Value is correct. Check rubric site record in the system. There are two rubric sites. First is the kernel one. Second is previous version rubric site. If new version not stable, rolling out undo able to return to previous version. The command is kubectl -n naming space rollout undo deployment is resource type / deployment resource name -2 version equal to value 1. The version number we retrieved from rollout history command. Let me start rollback. Check rollout status. Rolling out in progress. Almost done. Check deployment detail. Successfully rollout. Next, check the undo rollout app version. The number should be v1. It's correct. 2 demos were completed. Today we learned what is deployment and then introduced rolling update concept. Next, demo rolling update with set image command. Latest, demo use YAML file to rolling update. Thank you for watching all sections. I hope it was help. And it was, do not forget to like it. If you want to notify whenever new videos comes out, then subscribe to my channel. If you have any questions or something was not clear in the video, please post them in the comment section below, and I will try to answer. Thank you and see you in the next time.